Okay, in this video we are going to take apart an object to find forces internal to that object, just like we did in the previous video. This time though, we're taking apart a truss instead of a bent beam, and my goal is to find the force in member FH. So the goal here will be to find the force in member FH. So that's this one right down here. Okay, we have a 10 Newton force. Now, in practice, if this was a truss of actual size, that would probably be a much larger load. But I'm making it a 10 Newton force on this theoretical problem here. We would start by figuring out the reactions at the pin connection at B and the wheel at A. So if I look at the truss as one solid object, so one solid object, we've got a pin connection, so I'd have a BX and a BY, and we've got a wheel at A. If we do sum of the moments around point B, we'd get 10 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that would be in the positive k-hat direction. And then plus the wheel, which is A, times 10 plus that same distance 14 plus another 6, so it'd be A times 20, and that would be in the negative k-hat direction. So therefore that force at A would be 140 divided by 20, which would be 7 newtons. Okay, then if A is 7, then BY has to be 3, and BX would have to be 0. Okay, so we've got our reactions. Next, we'll take this truss apart into two halves, and I have to decide where to take it apart. Now, if I took it apart along this yellow line, oops, if I took it apart along this yellow line, then the internal forces that I'll find would be the forces in these two members. I won't get any information about FH. So what we need to do is try to think of a particular place to take this truss apart so that the forces in member FH will show up as acting on either the left half or right half of the truss. So if we do that, you might be able to see we could cut it down this line right here. So this is where we'll make our slice, and think of the truss now as made up of two half trusses which are connected together by these three beams, EG, FG, and FH. So I will now draw the right half, which has the force at B, which is 3 newtons up. It has this member, EG. It has this member, FG. And it has this member, FH, acting on it. And then the left half has the wheel at A, which is 7. It has the 10 pushing down. And it also has EG pulling and FG pulling and FH. Okay, I'm trying to find the force in member FH. So I think what we want to do is try to find the easiest approach. And I think the easiest approach is to look at the right beam or the right half of the truss. And for the right half, let's consider the sum of the moments around point G. That will then eliminate the variables EG and FG, because the moment around point G due to EG would be 0, and the moment around point G due to FG would be 0. So I'd have the moment around point G due to the 3 Newton force, which would be the 3 times that distance, which would be 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be in the positive k-hat direction, plus FH times its distance, which would be 1, 2, 3, 4. And that would be in the negative k-hat direction. So this would be 24 or minus 4FH equals 0. So FH would then be equal to 6 newtons. So we were able to figure out the force in one of the members of the truss by separating the truss into 2 pieces and narrowing it on just the one member that we wanted to figure out. We could have solved this also by the method of joints, but it would have taken a lot longer. So this method here is called the method of sections, and it can be used for finding the forces in members without needing to solve for all of them.